Hello, everyone. Good afternoon, good evening, good morning to everyone joining into the session. As I told you, please let us know where you're joining in from. Let us know how the sessions of NextGen 2024 have been so far. Your feedback means the world to us. This session is going to be really interesting. We are going to discuss leveraging surveillance and C2 data as a service for large-scale deployments today. We have Cyril Cronenberg from uAvionix, our expert, who's going to guide us through his presentation and help us learn more about the topic. I will take a few pointers from his slides as I went through his slides. It's a really interesting topic because, in the last 2 years, we've seen quite a lot of adoption of drone in a box technology. With that, with the number of drone in a box or docks in the market, the remote operations have multifolded in the last few years. And with remote operations and operations of nested technologies, one thing which is very common and critical is connectivity. Loss of connectivity equals loss of control, and we don't want that. That's not safe. So, what are the regulations around connectivity? What are the regulations around remote operations? Where is the industry heading? How are we making sure that our skies are safe and mapped? And how is C2 connectivity critical to remote operations? All these topics, I don't know the answers to these questions, but Cyril does, and he's going to help us with. He's going to guide us through his presentation, and we're going to learn quite a lot. As I said, Cyril Cronenberg. Maybe I'll give a quick introduction. Cyril Cronenberg is the Vice President of Business Development and Strategic Partnerships for uAvionix, heading up the strategic expansion of the rapidly growing offering of general aviation, UAS, and infrastructure solutions. With over 30 years of experience in the aviation industry, Cyril most recently served as the VP for Aerion LLC, where he was one of the founding members of the Aerion executive team responsible for the global deployment space-based ADSP. He has worked in numerous senior and executive aviation roles, which include the International Air Transport Association, KLM Royal Dutch Airlines, Martin Air, and the Royal Dutch Air Force. Cyril holds licenses as an air traffic controller, a pilot, a remote Part 107 pilot, and as a flight dispatcher. This provides him with a unique first-hand experience of operational requirements for a broad segment of the aviation industry. Welcome to NextGen 2024, Cyril. We are honored to have you, and we're quite excited to learn a lot from you today. So maybe you can give a wave and say hi to the audience.
Hey everyone.
Awesome.
Hopefully I can see the chat on the side. I think I see it live. So if anyone has anything they want to ask or any questions, I'll try and read that live as well. In the meantime, I'll put my presentation up here.
Awesome. But before you share that, Cyril, so that actually, quick reminder to the audience again, thank you for the segue. As Cyril mentioned, just feel free to drop in the questions in the chat box. Don't let them stop. Don't be shy. Sessions will be recorded and will be published soon. You can visit different booths in the expo section. Feel free to screenshot any of the slides, any of the session slides, and then post them on LinkedIn with the hashtag NextGen. The top 3 posts will receive special NextGen hampers. With that, over to you, Cyril. Let me stop sharing my screen and you can then get started.
Perfect. Let me go try that again. All right, let me know if you can see it.
We can see your screen, Cyril.
Perfect. Yeah, so here's my email address in case anyone has any direct questions they want to ask. But yeah, long history in the aviation sector. Really came from a lot of the what we now sort of start calling traditional aviation, both on the flying side and on the management side. And I think that provides a really unique insight into the world of drones. And a little bit about my company. We actually started off in the drone business before there was a drone business, because our company came from model aircraft. Paul Beard, our founder, was the inventor of the spread spectrum radio, which is now sort of the standardized remote control radio that really anything that flies used to run on. That company moved into ADS-B, where we started expanding that business into the general aviation market, and very quickly we became one of the largest companies in the world for general aviation ADS-B equipment. From there, we've started expanding into other markets, whether it's commercial aviation, the defense market, and even into space and other areas. But we really try and focus on the core piece of connecting things that fly in the air. We want to make sure that the airspace is available for anyone that wants to fly, and that is done in a safe way through communications. That's our core focus of the company. So when I came in this role, and with my background, I had heard about drones, had seen about drones, but we were very much in, I would say, in a sandbox mode. A lot of people were doing great stuff, and that's only fairly recently moved on to here in the US called Part 107. I would not want to start what everybody calls it, which is part of the problem, that every country in the world does things slightly different. But here in the US, we created this Part 107 rule. We started using visual observers as the eyes of what traditionally was the pilot in the aircraft. And we've barely tipped our toes into things like type certification, beyond visual line of sight waivers, which are increasingly being issued, but not enough to really make this commercially viable yet. And we've seen here in the US the first issuing of something called an exemption. So truly an unmanned operation under a Part 91 rule, where the FAA exempted certain rules out of Part 91 for that operation. So you're theoretically, you're just flying as if you were a crewed aircraft, and you're exempted for not having a window and not being able to look outside. And the FAA has spent a lot of time trying to figure out how to get there, and that's not unlike where I see Canada being, Europe being, and other parts of the world. Everyone is sort of tipping the toes in how do you get to a large-scale introduction of these types of operations, which means the reality for a lot of us, and there are exemptions. So those of you that are online that are part of the exemptions, you know who they are. But for the vast majority of drone operators, this is still the harsh reality. For those with a little bit of a larger footprint or a desire to fly further and higher, there still is a high reliance on radar technology, on ADS-B. We're still going out in the field with trucks and vans, people that follow the drone around through extended visual observers or even visual observers from a car. We've really not scratched the surface very much on how do you truly scale. And there are certainly some exemptions. Thinking Zipline and Google Wing are probably some clear examples there. Both are customers of uAvionix. But those are more the exception than the rule at this point. A lot of operations still rely heavily on a visual observer. I thought just making a little bit of a sidestep into corridors and detect and avoid and C2, and thinking back, well, how was it 40, 50 years ago or a little longer in the commercial aviation, in the crewed aviation world? So this gentleman is the inventor of air traffic control. He was the first air traffic controller that ever performed the job. His name is Archie League. And he did air traffic control sitting on a chair under an umbrella, bringing his lunchbox every morning, watching the planes at this airfield take off and making sure that they weren't flying into anything. If you start thinking about it, he really was the world's first visual observer. And the more you look into the details of where I see regulators going, there's a lot of parallels between the uncrewed and the crewed worlds that needed to fall into place before it could be commercially viable. If you think back to these days where Archie League was sitting at that airport under that umbrella, that doesn't sound very scalable very quickly, because you'd need an Archie League at every airport you would fly to with an umbrella sitting outside, and that obviously was not something that they were intending to do at the time. But that was what they had back in the days. So a lot of things have happened since the early days of commercial aviation. The regulators built a lot of standards that are very common in that world. AIS is one, so define what information you need to fly, define the format of that information, set the standards on how you communicate those. They defined what airspace was, what safety requirements were. They defined what separation standards were. And my favorite three are the three on the bottom. To do all that, they set standards for how you communicate, they set standards for how you navigate, and they set standards for what you do for surveillance. And surveillance can be as simple as a pair of eyes looking outside, and it can be as complicated as radars or ADS-B or even more advanced technologies that can be used. But most importantly, standards were created. And they, in short, became the code words AIM, ATM, and CNS. So ATM is what we currently call air traffic control, air traffic management. AIM is aeronautical information management, everything that goes into creating the information needed to conduct those flights. And CNS is communications, navigation, surveillance. You need all three to do commercial aviation safely. So let's jump back to the corridors. A lot of us think about commercial drone operations in terms of corridors, and we think that way primarily because of the integration problem that a lot of drones will face when they fly beyond visual line of sight, because how do you separate yourself from other traffic? There are a lot of people that fear words like corridors or ranges or whatever it is, but to me, a corridor is nothing different than a type of airspace. And what you see here on the map is sort of my home right next to Washington Dulles. That is one big corridor. I have all kinds of nice lines around my house where I can fly, cannot fly, but it doesn't apply just to me as a drone operator. It also applies to me as a general aviation pilot, because there are certain areas where I can go, certain areas where I should not go, and the requirements for these areas change based on where you fly in those corridors. In some areas, I don't have to talk to anyone. I don't have to be seen. In other areas, I need a transponder and a radio. All of this is published. It's publicly available through the AIM. I can pull these maps. I have applications where I can run them. And in the world of crewed aviation, we all accept this as the standard. Very rarely is that challenged. And when it's challenged, it's typically around an event where all of a sudden the airspace is closed in its entirety. Let's think the Super Bowl. That very often leads to people being uncomfortable because now they can't fly. But in general, all participants in this airspace understand the rules and work nicely with each other to follow those rules. And all that separation that is happening is very much based on rules and technology. So lay the communication, navigation, and surveillance over that, and think from a drone perspective. In these corridors, there are comm requirements. So if you fly, for instance, in the dotted area, within that area, you need VHF. You need to have a certain navigation performance, and you need surveillance. You need transponders, and you need to be able to see those aircraft. So when you lay over the UAS piece there, those comm requirements are really what in our world is called C2. So it is not uncommon for the manned aviation world to say, well, if you want to fly to Washington Dulles, it doesn't matter what type of aircraft you have. If you fly a little Piper Cup, you can go. But the minimum requirement is you have to have two-way communication. So very similar to how I see increasingly regulators treat the unmanned world, is where regulators say the more dangerous or risky your flight is, whether that's for airspace safety or because of your aircraft being heavier or because you're carrying passengers, the heavier these requirements on COM, on C2 are going to get. You have to be able to perform to a certain standard. What is not happening yet is the regulators actually telling you what technology to use. In most cases, actually, they're not telling you. But what I'm seeing increasingly is they're telling you to what performance level you need to be able to do that. When you look on the nav requirements, very similar. A lot of us, I've seen hundreds, if not thousands, of drones with all kinds of sellotaped stuff in it, and people have a GPS in it. And usually my first question I ask, being an aviation nerd, is, well, what's your GPS performance? I'm always surprised how many people don't know that. How accurate is that GPS? What's the heritage of that GPS? How do you know it's functional? So there are technical standards such as a TSO, which are very common in crewed aviation. Things like INS that are very common in crewed aviation that are not necessarily always adopted into uncrewed. But they are important because when you're starting to fly near or in cities where the chance of an incursion with a crewed aircraft is higher, or where an air traffic controller is starting to get interested in your flight, the accuracy and integrity of that GPS position becomes increasingly relevant. If you're pushing an ADS-B transponder with your GPS, the integrity of that GPS becomes very important, because otherwise your ADS-B position becomes unreliable. And the same can be said for surveillance requirements. If you're flying out in the field in a military area where there's zero chance of any other aircraft flying, or you're flying underneath a bridge near a big structure, the requirement on your surveillance might be very different than if you're flying very close to a major airport where you could see all kinds of traffic. So a lot of misconceptions still around the concept of corridors and detect and avoid and C2. We still very much see corridors as a means to keep traffic away from other traffic, or to sort of confine drone operations into a single area. But I don't really see it that way. The increasing use of corridors or how do you say that, UAS type airspace is more of a new type of airspace, and you can see that in Europe with the increasing use of the word uSpace. We're not doing that here in the US yet. Canada is not doing that yet, but we are clearly seeing a move into that direction where we're defining a piece of airspace where drones mix in with crewed aircraft by defining what are the minimum requirements for that airspace to operate in there, both from a surveillance perspective as a C2 perspective, but increasingly also you see that on navigation, or type of what do you need to have to get your position information and to share that information with other participants. So the question of how is that managed is an old one. We all started off with UTM was going to be the future. I personally still don't know exactly what UTM exactly is, but there is going to be some form of control, whether that is fully automated, self-separated, or if it's done purely based on capabilities of participants. But something needs to happen there, and it's still unclear to me what exactly that will be. Increasingly, we see service providers for some of these services that take part of that role, and that's definitely the direction that we see here the US and Canada go into when it comes to visual line of sight, beyond visual line of sight flight. So back to current day. Integration of airspace is still happening largely under, I would still call them corridor projects. Corridor sounds a little bit linear, but that can be just a large square piece of airspace where operations occur. But it is still very much managed by state endeavors, whether it's run by a university or run by a private entity. But still, these things are very much large infrastructure developments or completely isolated areas where drone operations take place. Separation is very much based on the capabilities of the corridor. And increasingly, we see corridor providers or operators of these large ranges also start managing the information that needs to be shared with the operators and manage the systems that can be shared with operators such as C2 and the AA system, because that becomes one of the critical items in expanding drone use. If 5 people are going to fly in an area and all 5 need to be buying radars, that is never going to get to a commercial viable solution in the future. So the demand for operations, mixed operations, will absolutely keep increasing. We very clearly see that. As a company, our unmanned business is growing at a much faster pace than our crewed operations. So you can see that shift happening. And individual operators very increasingly start getting closer to each other. Here in the US, there is a big project undergoing in Texas where the FAA is actually starting to encourage multiple package delivery operators to nearby each other start operations, and starting to focus on how do you do that in parallel with other operators? How do you coordinate those? The equipment and the systems that all of them use will also start overlapping. We already have customers that are in the same area that use the same backend system for their detect and avoid data or for their C2 data. And that's definitely an area that is expanding quite quickly. So uAvionix contributes, besides our avionics itself that is on many drones in the world, we contribute very much on 2 fronts there. We contribute through what we call Skyline, which is a managed command and control. And we contribute to what we call Flight Line, which is a managed detect and avoid network. So one is aimed at ensuring that the C2 link for drones meets the performance requirements from a regulator, the high performance requirements for a regulator. So if you're just flying with a hand controller, a small DJI, you're not very likely to use a managed C2 link. But if you're flying a Cessna Caravan over hundreds of miles between large cities, that C2 link becomes much more important, and it becomes unviable to manage a network of radios by yourself. So on the Skyline side, we developed what's called a link manager on the aircraft, which is able to connect multiple sources of C2. And unlike a lot of the existing solutions out there that still require pretty manual link changes, this fuses the links in its entirety. So all packets that go through the drone to the ground control station, all in the cloud, manage to get their way from the drone to the ground and the other way around using whatever spectrum is available. They go over C-band, SATCOM, LTE, ISM, depending on what that network looks like. But it guarantees a very high level of performance for that C2 link. On the Flight Line side, and this is something that we increasingly see also in other parts of the world, we started deploying ATC grade ADS-B receivers, not unlike your more crowdsourced networks like FlightAware or FlightRadar 24, but with a very clear focus on data integrity. This is data that can be used for air traffic control, but we're focusing on low altitude. So a lot of gaps are typically there at low altitude within ATC data, and that is where your GA threat will come from. So that's where we focused our deployment with Flightline. This data is all centrally managed. We validate that data through multilateration. We provide a validation score to the customer. And through an API, the end customer is then able to feed this into their own front end, whether that's GCS or their own detect and avoid front end application. And in some cases, they use our UI. Both of these combined, Flightline can be fed into Skyline. As you can see on the left there, you see some traffic in there. They become not the entire operation, but they become a big part of ultimately what is the operational back end for beyond visual line of sight flight. So on the connectivity side, as mentioned, we currently support 4 major radio links, ISM, which is really US-Canada oriented, LTE, where we use a network agnostic approach. So the radio will connect to any network it finds, and it will determine the best link during flight. We have dedicated spectrum through C-band, which increasingly throughout the world is being reserved for UAS command and control. It's specifically a command and control non-payload link because of its high performance. That is a long-range radio up to 100 miles on a ground radio to the aircraft. And then Satcom, we have started integrating with Inmarsat and Iridium, and are building specific radios for drone operations that fit into that mixed mode of C2. So depending on the mission, some customers will use only one and can fly perfectly alone on LTE. Other customers are fine with ISM, which is unprotected and therefore a little bit higher risk of loss of that data, all the way up to a very high level of quality C-band, with the ability to actually certify that for things like passenger carrying vehicles, urban air mobility, as well as Satcom, which has that same heritage. On the flight line side, we have deployed with several of our customers at a larger scale. Florida Power and Light, some of our large customers in the US. We have worked very closely with Civil Air Patrol here in the US to roll out. But the end result is that we now have several states throughout the US where this data is covering 100% of the state down to 500 feet. All this data is available over an API, so it could very easily feed a front end, whether that's a Kongsberg front end or an UNRWA front end or somebody else's UTM system. For us, that's all possible, but it makes it easier for operators to pull in data that's already there without having to go and install a whole bunch of hardware themselves for their operation. Recently, we did an acquisition. We now also brought in the optical piece. So Iris Automation is now also uAvionix, which is an optical detection of anything that flies, whether it's a bird or a drone or a small plane. And we're using that effectively as your non-cooperative element. So cooperative and non-cooperative can be done through optical. All of that has resulted into, in the US, we're one of the 4 companies that as an operator have received an exemption from the FAA to fly our aircraft. And that exemption was entirely based on the DAA system and the C2 system, which has led to many of our customers waivers for that same, with that same backend. Our customer use and the users of this system are typically not single operators. They're pretty much enterprise type operators. So oil, gas, linear inspections, a lot of law enforcement use, DFR type use cases, and increasingly also international. We've got a lot of customers in the UK and in Europe, and also increasingly now in Asia Pacific and in Latin America. So to close it off, we went from complete segregation of drones and sort of a hobby environment into a full integration where actually that VO that used to be outside is now inside, managing that flight through sensor information, both on link quality, C2 quality, DAA quality, but it has become in all our operations an internal function. Our electronic observer, the way we call it, is no longer outside, but has a series of systems inside. We'll always see corridors remain, but over the time, we believe that it will get more and more automated. And you can very well see that function move even more to the right in a network operations center, where an electronic observer manages multiple flights for airspace management, or an RPIC manage multiple flights because of very highly reliable C2 and DAA. So we feel that these are some very critical elements in the development of large scale beyond visual line of sight flight, and these are the two that we are currently very actively engaging in with our customer base. So that was what I had for you at this point, and I said I was going to look at the chat, but I was actually not able to do that because I have my full screen on. So, but I'll hand it back to you, Michelle.
Thank you so much, Cyril. That was really informative and it was quite helpful. We do have few questions and I'll take up those one by one. And I also have a few questions of my own, if you don't mind. So once we take the questions from the audience, maybe I'll take a few. So uAvionix has great capabilities for, so this is a question from Christopher. uAvionix has great capabilities for communication and surveillance. From your perspective, who should be responsible for buying infrastructure to support drone operations? If the ANSP doesn't buy it, will it be trusted?
It's not an easy one to answer. I wish I could say the state will just buy it for everyone, and we have seen those examples. The state of North Dakota is a great example. We are currently also deploying hardware at a state level in Oklahoma, where the funding also comes more centrally from the state level. We also have seen large enterprise customers funding the deployment of this technology. Florida Power and Light is one of those customers. They are deploying the capability for DAA and C2 in the state of Florida, but they are self-funding that to support their operations. In all cases, the philosophy behind that is, in my view, fairly similar. They all believe that technology is shareable between operators. Like once you have a DAA layer in a state, whether that's North Dakota or Florida, depending on who funded that data becomes shareable, and it becomes monetizable as well. So Florida Power and Light could allow us to resell the data that was derived from their system to operators that are flying in the state of Florida for DFR or for package delivery. There's really no reason for somebody else to then duplicate that capability. I still think that state funding is probably the main driver for the next foreseeable future. There are not a lot of companies that have the depth to do it themselves, but that will change over time. I think once drone use is getting a little bit more commercially viable, we will see more entities deploy. We are self-funding it. The entire flight line deployment throughout the U.S. Our goal is within the year to have 100% coverage in the contiguous U.S. For drone operations, and we're doing that with our partners through a model where our partners help us roll that out, and we provide that data to them and to others that might want that data for their own operations.
Awesome. So that was quite interesting. And one aspect, based on your experience, most private entities who are, enterprises who are adopting this technology, are they really making the data available? Is that happening, or are they trying to are they reselling the data and making a business model out of it?
So the model that we have with Florida Power and Light is exactly that. It was a model where they funded the deployment. We were the deploying entity, and we're able to resell that detect and avoid data in a commercial arrangement with Florida Power and Light. So that's actually a very useful way of doing it, because they need it anyway. They need to operate, and hopefully that makes it cheaper for others to use down the line. In the case of North Dakota, it's more of a commercial entity that was formed under the state. Oklahoma, it is really done under the umbrella of a test range, but increasingly also supporting other operators. And there's at least 6 or 7 large-scale deployments either in the works or already on their way. Texas is a real big one. But we're also seeing the same happen in Canada. We're involved in Alberta with a large corridor where it's not a single operator, it's multiple operators sharing the same infrastructure. And I see the same models starting to develop in Europe as well. So I think it's viable. It's definitely needed to make commercial operations happen.
Awesome, thank you for that. And also, maybe history teaches us a lot. And you took up aviation, general aviation at the start. Maybe could you share how if you do know, how did the story unfold maybe 50, 60, 100 years ago? Is is the same story, can that be replicated for UAS corridor mapping and detection?
I personally think so. I mean, things that were unthinkable 10 years ago or 5 years ago are now very accepted. And we're also seeing regulators that historically were shying away from telling crewed aircraft that they needed to be seen into actually mandating it. We're seeing an adaptation of ADS-B on UAT in other countries than the US. Electronic ground security is one of those topics that you can clearly see is starting to gain a lot of traction because regulators understand that without it, it's going to be almost impossible to solve this dilemma. So I'm convinced that 5 years from now we will have significant expansion in the ability to fly large-scale drone operations, and that's partially because we've created standards, we've created ways of communicating between crewed and uncrewed, and we've created airspace rules to define what that needs to look like. And but it's not going to happen tomorrow. I think we'll probably still be in the corridor mode for the next 2-3 years or so, unfortunately, and with exceptions. I mean, Australia, parts of Africa where the Zipline and Wing have large operations, Australia where they have large operations, they clearly cracked the nut, and partially that is because of a very homogeneous crewed environment that makes that easier to do. But yeah, I'm optimistic for sure.
Also, one more aspect that you covered was the fact that every country, every region has different regulations currently. And how did it happen for general aviation? Was there a central body that was formed to, make it a general sort of a regulation space? Do you foresee that with drones as well? Because U space is different, from the US, from Canada, and also the regulations in Australia.
Yeah, I always have to be careful. I mean, I was on many ICAO panels in my days, and I've seen the sausage making of international rules. At its best, it takes 4 years to create a rule, and its worst, I've seen it take 12 years. So, but unfortunately, that is the way it will end up going. Unless CAAs all come together and start adapting to each other's best practices, I think for now we'll still see international differences. A great example of that is Europe is going one direction with their ADSL standard that nobody else has. The US is entirely on ADS-B. Canada and the UK are entirely on ADS-B. So at some point in time, that will have to change. So either Europe changes or the rest of the world changes, but you cannot sustain two completely separate standards, because otherwise you'll just create manufacturing that is only applicable for Europe and only applicable for the US. So is it going to be 100% the same? I don't know. ICAO has a role in that, and I increasingly see ICAO start adapting things like talking about C2 and talking about UTM, and that's been actually a prime focus of ICAO for a while. But the focus for ICAO has for the longest time really been around larger drones integrating with crewed aircraft and not so much on the lower altitude problem. And I think that's starting to change now. So, but I definitely see rules being flushed out in the US. We're probably 3-4 years away from a first read of what Part 108 looks like. And Canada has issued some first clear rules that I think are very similar to what the US is identifying for Part 108. And I see the UK going in that same direction. So there's definitely some commonality to starting to happen. And as soon as you have commonality, ICAO will start publishing things at a more rapid pace. I think we're still too diverse at the moment to do that.
Awesome. That was very helpful. Maybe we'll take just one or two more questions. We're over time, but I guess the audience is interacting. So Lesiba is asking, please elaborate more on the assistance of Flight Line and Skyline regarding say, hear, and avoid. Maybe if you can open the Q&A section and see the question on the right.
Yeah, I mean, I'm happy to talk a little bit to Flight Line. If let me just, I'll go and actually try and share my screen, because I think that says a lot more than Let me see how I can quickly do that here. Chrome tab, line, there we go. So what you can see here is, this is just pretty picture planes on a map, nothing different than that. But if you look at Florida Power and Light as one of our customers, so there is a pretty substantial deployment of sensor network throughout the state of Florida. And it goes down to the airport level. So I'm picking up here an airport like Tampa, where we've got the ground traffic. So there's a lot of sensors are deployed for an existing customer. So we've gone through the effort with that customer to get these sensors and this data network certified through waivers, and in North Dakota through an exemption. And the philosophy here is that if another operator, say the police department in Clearwater, wants to start flying beyond visual line of sight and is in the need for detect and avoid data to do that, they have multiple choices. They can deploy their own radar, they can deploy their own sensors, they can deploy an optical device. But what we're trying to get to is that they can pull in this this cooperative data, this ADS-B data, as an element in their overall safety case. And if there is a radar, which in Florida where we have multiple ingested in this system, then that radar data can become the non-cooperative piece. But the whole philosophy is that you're taking the burden of proving the system out and demonstrating to the FAA or which other regulator it is how good that data is, or that the data is good enough for separation. And you're effectively just letting the customer point to an existing system that already went through that certification process. And we're starting to do the same in Europe. I'll just quickly show you for the UK. That sensor network is very quickly being deployed as well. We're doing that in partnership with British Telecom, who have been helping us host some of these sensors. But the same philosophy applies there. There is no need for each operator in the south of England to go and deploy their own sensor network. Instead, they can just take, I see Chris is online, they can take the OneSky application as a front end, and OneSky can pull in through an API the data from Flightline, and that becomes the layer for detect and avoid. So for cooperative aircraft to see cooperative aircraft. If you're in an airspace like near London, where there's a requirement for certain technology, or even better in the US under remote CVL, where ADS-B is a requirement, then that becomes pretty much 99% of your requirement for detect and avoid when you have that type of a capability. So that's sort of the underlying thought behind Flightline, and it's very quickly expanding. 6 months ago, there was nothing. So we've very quickly started deploying that, and I think we're 6 months away or so from doing that at least in the US at a national scale.
Awesome. Thank you so much for that explanation, Cyril. I hope that helps, Lesiba. We're quite over time, and I would love to take more questions. We have maybe just Lesiba's follow-up question. Anything in Africa, sensor network?
Not yet. Happy to participate. So our concept here is that the sensors are high quality and very low cost, and our partnership approach has been rolling that out with partners locally. So whoever's the first to help us gets probably the best deal out of this. But ultimately, we are relying on partners. We don't have our own team going out and installing those. We do have operators in Africa that work with us, so very likely we'll start seeing some initial sensors there. But we certainly would like to work with any operator in the area.
Awesome. So Lesiba, if you're interested and you know the right people there who could get in touch with Cyril, feel free to share his email. That was all our time. So thank you for joining, Cyril. Thank you for this really informative session. I learned a lot personally, and I have written notes, and I'm going to follow up on it. And I hope everyone in the audience learned a lot as well. Please feel free to give us a feedback in the wall of love, Cyril and everyone who've joined in. Thank you for the session, and we can.
Perfect. Thanks, everyone.
Thank you. Goodbye.